Welcome back, everybody. Now that we've gone through the authentication part for MAB, and we've seen both methods of using MAB, so that was MAB and MAB EAP, and we also looked on the different types of configurations on ISE. So we did both MAC-based authentication based on the client station ID, and also username password-based authentication. Now we're going to go through and identify what are the available authorizations options we can push from the ISE server in order to basically, let's say, restrict client access to the network. The first thing we need to understand is that it really doesn't matter what is the authentication method used. So it can be MAB, it can be 802.1x, it can be essential web authentication. The authorization policies and the authorizations which are available to us are pretty much the same. So we're going to go through those by making use of the previously configured MAB authentication. So the most commonly implemented authorizations is first to dynamically allocate a VLAN from the authentication server to the client. And that really depends based on if the client it's in the data domain or if the client is in the voice domain. And based on that, different types of configurations need to be done on the ISE side. So basically, if we look here on the diagram, so what I did so far, we've previously said that the client was R2, which R2 was in the data VLAN. So this was the data VLAN. And switch 1 was using ISE1 and radius to perform authentication of the client. Now, if we look on the switch configuration and we do a show run interface FA102, we see that the client is statically configured in VLAN 29 and it matches the diagram. Now, in order to receive a VLAN from ISE server, first of all, that is an optional config. If I don't receive a VLAN from the ISE server, a data VLAN, then the switch, once the client is authenticated, will put the client in the locally configured VLAN, which was VLAN 29. If I push a VLAN from the ISE server, then we will see on the configuration side, and once the client is authenticated, that the dynamically VLAN received from the ISE server will replace the VLAN locally configured. And as we're going to see, it doesn't mean that the client, the switch config is changed. So for example, if we'll put the client in VLAN 34, it doesn't mean that we're going to see on the switch side something like switch port access VLAN 34. It's just that the client is put dynamically in the new assigned VLAN. Things are a bit different if, for example, we take the IP phone, which is this one, and this guy is going to be in the voice VLAN. So we want the IP phone to be in the voice VLAN. So if we do the same config for IP phone, meaning let's say we're going to do MAB type authentication or 802.1x authentication, then in order for the switch to allow the IP phone to join the voice domain, then in this case I need to receive the voice VLAN authorization from ISE. So again, in order for the switch to allow the IP phone to join the voice VLAN, I need to receive that authorization from ISE, and this is not optional. If we look back at the slides in here, in order to perform VLAN assignment from ISE, either for the data VLAN or for the voice VLAN, I need to enable on the switch side the authorization network command. Because what we need to remember is that whatever authorization I received from the radius server, in order for that authorization to be applied by the switch or by the wireless LAN controller, I need to have the authorization enabled. So without this command, the switch will receive the authorization from ISE, but it will not be able to apply that authorization on the port of the client, which means that authorization will basically fail. So the client will be denied access to the network. Except the VLAN assignment, we can also restrict client traffic onto the network by using access list, and we have several options for this. One of those would be, for example, using something which is known dynamic downloadable access list. This is a Cisco proprietary feature, and we've seen also the DACL functionality when we speak about, for example, out proxy or basically cut-through proxy, for example. We've seen that functionality in there. what we need to know for using DACL with MAB or with 802.1x is that when the switch will receive the DACL from the radius server, in order to apply that DACL on the port where the client is connected, depending on the switch version we're running, if we're running a switch code before 12.2.55, in order for the switch to be able to apply the DACL, it needs to have a pre-configured access list applied on the port. So if the switch does not have a pre-authentication access list applied on the port, then when it receives the DACL from ISE, it will not be able to enforce that, and it will not be able to apply that, which means that, again, the authorization will fail, so the client will be denied access to the network. So depending on the switch code version you're running, you need to be careful with this functionality. The other option would be to use something which is called filter ID ACL. Again, the same functionality as in auth proxy or cut-through proxy, meaning that if I use the filter ID ACL, then the ISE will push to the switch only the ACL name, and that ACL needs to be locally configured on the switch. The third option would be to use the per-user ACL functionality, which this really depends. I have two options to make this work. I can either configure the radius server, so the authentication server, to push to the switch the access this name, so pretty much the same as it was with the filter ID configuration, which means that that access this needs to be again locally configured on the switch, or I can configure the radius server to push to the switch the ACL content. So it's up to me to decide which option do I want to use. Basically, the main difference being that the question you want to put yourself is, do I want a centralized policy? So meaning I will have the ACLs configured on the radius server, or do I want a decentralized policy, which means that I will have the ACLs configured on individual switches in the network. One other option and one other thing you need to be aware of is that DACL and per-user ACL are Cisco proprietary, because, for example, the Cisco per-user ACL uses the Cisco AV pair, which again, that means is supported mainly by the radius implementation of Cisco. The only standard available option for you would be to use the filter ID functionality. Based on the access list type I would want to use in order to restrict client traffic into the network, I would need to additionally configure some options on the switch side, which those would be, we're going to see what's the scope of device tracking and what does that mean. And also the authorization network is pretty much the same requirement as was with the VLAN. So basically, whatever authorization I received from the radius server, in order for that to be applied, I need to have the authorization network configured. And as we've seen in the, for example, in the authentication proxy configuration, in order for the DACL to be applied, we need to have the radius server VSA send authentication configured. Let's go to the configuration part, and we're gonna repeat whatever we speak so far, so mainly the commands, and we'll get a better understanding of why would you need each command to do what. So looking again on the diagram, what I would want to do, let's skip the IP phone. So at this moment, from the previous task, I have R2 already authenticated on the network using MAB. So first, let's go ahead and, for example, authorize the VLAN. Let's go on switch 1 and see what was the basic configuration. So show run, begin AAA. So I had, first of all, AA enabled. Then I had configured the integration with the ISE server, which was 172.16.3.100. I can go ahead and remove 1.100, which that was the ACS server. So let's do this first of all, and let's remove the ACS server because I'm not using that. So let's do again show run, begin AAA to see the relevant config. So I have AA enabled, then I have integration with the ISE server, and then I have the global authentication.1x configuration. And at the port level, I just have MAB enabled, which I was using MAB IP, and I also have authentication enabled. Let's change this to be just MAB, FA102, and let's say MAB. The session, let's see that the session was authenticated, show authentication sessions. So the client was authenticated. Now let's go on ISE and configure the authorization. First, let's just assign the VLAN. So at this moment, we have, if we do a show spanning tree interface FA102, I see that R2 runs in VLAN 29, which is the same VLAN as it configured on the switch on the port level. Show run FA102. So it's the same VLAN as configured at the port level. Let's go on ISE and let's change the authorization. Now at this moment we're matching on the default authorization rule, which just grants access, which pretty much what this means is that Radius will just send an access accept message without any attributes. Let's go to policy, and I want to say results. I want to add an authorization policy, so authorization profiles. Let's say add, and call it MAB wired, let's say. Let's say MAB wired profile. And what I want to do is I want to assign a VLAN. When you do this, it says edit tag ID/name. So what I can specify in here, I can say either the VLAN number, either the VLAN name. If we, for example, you go on the switch side, and we do a show VLAN brief, we see that the VLANs have also some names. So this is the VLAN number, and this is the VLAN name. So basically, I get to choose on the ISE side if I want to push a VLAN name or a VLAN number. It's really up to you. There is no difference in the functionality. So let's go on ISE. And I want to say I'll assign VLAN, what was that? For example, let's take VLAN 17, for example. So I want to put R2 in VLAN 17. And I'm going to go ahead and say submit. So for the moment, I just want to assign the dynamic VLAN and say submit. Let's go to the authorization policy, and let's create our own authorization policy, which we need to insert it before the default one. So I'm going to say insert new rule above. I'm going to give it the name of MAB wired. And at the condition, let's say I want to say select existing condition from library. Let's see if I have any conditions configured in here. I'm going to say compound. And I'm going to say if wired MAB. So basically I'm saying if the session is going to be of type wired MAB, which means I'm using MAB authentication service type called check, and I'm using that for an Ethernet port. Then I want to apply the previously configured profile, which was called, so standard, it was called MAB wired profile, basically assigning the dynamic VLAN to the port. I want to say done and say save. On the switch side, of course, I also need to add the AA authorization network, which this was not required for basic authentication. So let's say AA authorization, network default, and group, which was ISE radius. It was the name. Let's verify that. So it was ISE radius. And let's do a debug radius authentication. Let's say show log. I have level debugging on the console, and let's say show authentication sessions, and let's clear the authentication. Clear authentication sessions, and session ID would be this one. So this will enforce the switch to trigger the authentication process again. Let's wait for the process to complete. And it said authentication successful for client, so the MAC address of R2, and also it said authorization succeeded for client. So let's say undebug all for the moment, and let's look through the debugs output. So this is the request from the client side, from the switch side, which says I'm doing a service type of call check, which means MAB, and I see the username. Let me do no logging cancel for the moment. So I see that when the switch sends the radius request to ICE, it uses a service type of call check, and then the username and the password have the same value of calling station ID, which is the MAC address. The user password is not shown in clear text, but it's basically also the MAC address. And then the calling station ID, I see is that the MAC address of the client, which is R2. It sends that request to ICE, and I get an access accept message, which means that authentication was successful. And I should also receive the VLAN number, which I do as part of the authorization. So this would be the VLAN authorization, and now I get the VLAN number. So what this means is that if I say, let's say show authentication first, show authentication sessions. So I see that authorization is successful. Let's say show authentication sessions interface FA102. What I'm looking for is the VLAN policy. So now I also see that the VLAN was dynamically assigned by the switch. If I do a show by ICE, if I do a show run interface FA102, I see that the command remained configured on the switch port. So as I said, ICE will not actually change the configuration of the switch. We'll just enforce the switch to put the client on a separated VLAN. Which this means is that if the locally configured data VLAN will be used by the switch only if it doesn't receive an authorization as a VLAN from ICE. Once it receives the authorization from ICE as a VLAN, it will put the client in that VLAN. And the way you verify this is you can say show spanning tree. So I've seen that in the show authentication sessions command in here. If I do a show spanning tree interface FA102, I see that now the client, which is R2, runs in VLAN 17. So that's why it's not a good idea to look at the show run interface command in a live network when you have MAB or .1x authentication, because the show run command does not tell you what's the actual VLAN number that the client is running into. So let's go back now because if I look back on the diagram, because actually R2 has an IP address from VLAN 29, what ended up happening is that R2 lost connection to the network. So R2 has an IP address from VLAN 29. But I used a different VLAN just to show you that the locally configured VLAN it will be overridden by the radius policy. So let's first go back on ICE, and basically let's go on results and change the VLAN to VLAN 29. Go to authorization and authorization profiles, MAB wired profile, and I'm going to change this to VLAN 29, which is also the one locally configured, 29. And I'm going to say save. Next, let's try and, for example, design from ICE kind of restriction to the network, which would be an access list. First, we're going to look at the downloadable ACL functionality. So let's go and first configure the downloadable ACL. I'm going to give it a name of, so let's say add. Let's say the name is wired MAB DACL. And the content, let's say, would be permit IP any. You need to make sure that you configure correctly the ACL content because ICE will not validate that for you. So make sure that you don't have any spaces and the command syntax is correct. Let's say submit. And now I want to apply the DACL on my authorization profile. So I go on the authorization profile and I say DACL name is the one which I've configured, which was wired MAB DACL. Save. Before I reinforce the authentication process on the switch, let's go and check the live logs and see if I match the proper authorization rule. So as I said, it's not enough to make sure to see that the client got authenticated and authorized. You also want to see on ISE that you match the proper authentication and authorization policy, which means that the ISE configuration is correct. So let's go on the latest authentication. I already see from here that the authorization profile which was applied was MAB wired profile. So it's this one in here, which means that if I go to policy authorization, that confirms that I matched the third rule, which was this one called MAB wired. But let's go to the live logs again and look into the details. So I'm going to say details in here. And I see that authentication was succeeded. And I see that I matched on the layout protocol MAB, which this relates to the authentication policy. And I was assigned the MAB wired profile, which this tells me what authorization policy I matched. And the authentication protocol was PAP ASCII because I'm not using the process host lookup functionality. So now let's go on the switch side and enable the DACL functionality. In this moment, I have the AAA authorization network command configured, but as I said, I also need a radius VSA send authentication for DACL to work. For the moment, let's not add it, so let's say debug radius authentication and see what happens. Let's do configure terminal and then logging, cancel debugging. And then let's say show authentication session, and let's clear the session. Session ID, this one. Let's say undebug all for the moment. And let's look at the process when this finishes. Show debug. So debugging is stopped. Type still have some outputs from previous debugs. Let's wait for it to finish. Let's say conf t no login cancel. What I see is that the authentication is successful. So this message means that I got from the radio server an access accept message, but I see further on that it says authorization failed. This means that the authorization attributes that were received from the radio server could not have been applied by the switch on the client. So now either the configuration on ISE is wrong, which means I receive the authorization attributes in a format which is not supported by the switch. Either I receive it in the proper format, but the switch is not able to apply those because of configuration issue on the switch side. Let's go and look at the debug outputs from, let's go and scroll up. And I can stop here. So basically I receive an access accept message from the radio server, and I also receive some authorization attributes. So I again see the VLAN number, being received, which is good. And I also receive the DACL, which is this one. So I receive the DACL name, but the way DACL works is that when the switch receives the DACL name from the Radius server, it needs to perform it needs to go to the Radius server and request to download the DACL content. And when it does that, it will authenticate with the DACL name that it was received and with the password of Cisco. That's why we need the Radius server VSA send authentication, so that the switch can actively go to the Radius server and ask for the DACL content. So let's go and say Radius server VSA send authentication. And let's say logging console debugging. Let's do debug Radius authentication again. Let's say show authentication sessions. And let's say clear authentication. I already see that the client was successfully authenticated probably once I've added the Radius server VSA send authentication command. Let's say clear authentication sessions, session ID this one. So let's wait for it to finish. So it says authorization succeeded for client. Let's say undebug all. And now let's look at the debug output, which starts from here. So the switch sends the Radius request with the call check, service type attribute, station ID, username and password. It receives an access accept message from ISE. It also receives the VLAN authorization with the VLAN number, which is 29. And then it receives the DACL name, which was this one. And now, because I have the Radius server VSA send authentication command configured, what ends up happening is that the switch initiates a new Radius authentication request with the username matching the DACL name, and the password, which is a Cisco, is not shown up, with an event saying ACL download, which this says that the switch requests from the ISE server the ACL content, which was permit IP any, which is received in here, in the format of Cisco AV pair. So the switch requests the DACL content, and the ISE server sends back the DACL content to the switch. Let's say show authentication sessions, which says authorization success, and show authentication sessions, interface FA102. And now I see that, so authorization success, by authentication server, and I see the access list name, which is this one. So now the switch successfully downloaded the ACL from the switch. Let's say show IP access list, and this one. I should see the permit IP any, which I see. Let's say show IP access list, interface FA102. I don't have any output, which means that the ACL was downloaded from the ISE, but it was not applied to the user, which in my case is the router. So it was not applied on the router, which means that most probably the router actually has no access to the network. If we go back on the diagram, I see that the router is directly connected through VLAN 29 with switch 1. So if I go on switch 1 and I say show run interface VLAN 29, and I go on router 2, let's say connect, and I go to router 2, and I want to ping the IP address of switch 1, which is 136.129.9. I have no access. This is because the switch was not able to apply the access list on the client's authentication. So from the authentication perspective, all looks good, but because the switch failed to apply the access list, it's actually like, it's acting like a deny IP any functionality at this moment. And this is because IP device tracking was not enabled on the switch. If I do a show IP device tracking, all, I see that IP device tracking is disabled. The scope of IP device tracking is not only used for .1x authentication, is also used, for example, for stuff like IP source guard, or for example, when we'll do central web authentication. The scope of this one is that the switch needs to learn the IP address of the connected client, because you'll always do the access list configuration on the Radius server side as something like permit IP, TCP, UDP. So you can use the IP or any kind of protocol, and you'll always put any in the source, and in the destination you can put either any or either something specific. But what the switch needs to do, it needs to replace the source any keyword with the actual client's IP address. So it kind of automatically configures a kind of an IP source guard, so it makes sure that once the client was authenticated, only the IP address of that client will be allowed to send IP traffic inbound. And for that to happen, it needs to have IP device tracking configured so that it can learn the IP address of the client. IP device tracking relies on, for example, on ARP packets. So once the switch will see some ARP packets from the client, it will learn the IP address of the client, and also works for any kind of IP packet. So when the switch receives some ARP packets or some IP packets from the client, it will automatically learn the IP address of that client. So let's go and say, let's enable IP device tracking. This is a global command, IP device tracking, and this should be it. If I do now a show IP device tracking, all, I see that it is enabled now, but still it didn't learn any IP address from the client, because at this moment all client's traffic is dropped. So what I want to do is I want to go back on the switch. Let's say show authentication sessions. To see that happening, I want to also enable EPM logging. So this will help us see when the switch actually applies the ACL on the port. Let's say clear authentication session, and session ID was this one. So I want to enforce the client to re-authenticate. Show logging. I have logging enabled. So now what I see in here is that it says the authentication result was success. And it says here that the access list was not applied because of event IP wait. So now the switch waits to learn the IP address of the connected client in order to apply the access list. So now if I say show IP device tracking, all, it still didn't learn the IP address of the connected router. Let's force this with port bounce FA102. So let's say configure terminal interface FA102, and let's do a shot, no shot. Sometimes IP device tracking is not as reliable as you wish it is. So let's do this. This will also enforce the authentication to process again. So now it learned the IP address of the client. So I received the authorization from ISE as a DACL. It says download request and download success. Then I am not able to apply the ACL on the client yet because it says IP wait. So at this moment the switch waits to actually bind the device tracking table with the IP address of the connected client. And once it will learn that, it will be able to successfully apply the accesses on the port. So now it says that it learned the IP address of the client as being 136.129.2, and it says the event IP assignment, and only afterwards it's able to successfully apply the access list on the port. So now if I say show IP device tracking all, I should see that it learned the IP address of the connected client on port FA102. And now if I do show authentication sessions, this is as well as it was before authorization success. Show authentication sessions, interface FA102. And this shows up as the DACL is downloaded, the VLAN policy was received, and authorization was success is being received from the authentication server. But what I want to verify is I want to say show IP access list interface FA102, which now confirms that the access list was applied on the port facing the client. We can also do this with show EPM session, and let's say interface FA102, for example. Show EPM session, I should put the IP address, let's try this one, IP 136.1.29.2. And I see that the DACL was correctly applied this time on the port of the client. So if I go now on R2 and I want to ping switch 1, I should get connectivity. So the problem was the first time the problem was that I didn't have radius VSA send authentication enabled, which means that the switch was not able to download the DACL content from the radius server. Then it succeeded to download the content, but it was not able to apply the ACL on the port because IP device tracking was not enabled. Basically, IP device tracking, it requires to be enabled whenever you have an ACL type of authorization received from the radius server. It doesn't really matter if that's using a DACL type or a filter ID or a per user ACL. Let's try and change the authorization on ISE from DACL to, for example, filter ID, which means that I want to go on ISE. We can also see on the logs, if I'm still here, I can actually see that the first authentication, which let's say is this one, so this one, for example, this is the actual authentication of the client, which was R2. And I also want to take a look at the second authentication, which was actually the DACL download request from the switch. So ISE authentication succeeded, and I'm matching the allowed protocol MAB, which means the authentication policy, and the authorization profiles MAB wired profile, which means the authorization policy. So this was the actual client authentication. Now, the second one was used, as you can see, by the switch to request the DACL content. So you see that the switch authenticated twice using the DACL ACL name. In order to change the authorization from DACL to, for example, filter ID, I just need to go to Policy, Results, and I want to go to my authorization profiles. And I want to remove the DACL from MAB wired profile. I want to remove the DACL authorization, and I want to use, for example, the filter ID one, which is this one. And let's say the name would be VLAN 29. And then apply. You see that automatically when you do VLAN 29, ISE automatically says .in. .in, it will actually instruct the switch to apply that ACL in the inbound direction. If we remember for when we've done the authentication proxy configuration, for example, we had to do that manually on the ACS side or on the router side so that it can actually be enforced in the inbound direction, because by default was the outbound direction. So I want to say just submit for the moment, save. But because I'm using a filter ID ACL, I need to go on the switch, and I need to locally configure that access list. So IP access list extended, VLAN 29, and let's say permit ICMP any, and permit TCP any, and finally let's say permit IP any. I'm just putting some more input in here so we see the difference on the authorization side. First, I need to clear the authentication session. So let's say show authentication sessions. Oh, this was R2. So I need to configure this on switch 1. So let's go on the switch and let's say configure terminal, IP access is extended, VLAN 29. And let's say permit ICMP any, permit TCP any, and permit IP any. And let's say show authentication sessions, clear authentication session ID, this one. So it says that authorization succeeded, but I'm still in the, it says event apply in here. Let's look, let's say show IP access list, show IP access list, interface FA102. It didn't get applied because of this. Let's again inspect the show IP device tracking table. Show IP device tracking, well, it did, it finally learned the IP address of the client. So it took a while to learn the IP address of the client. Let's look at your authentication session, show authentication sessions. ISE authorization success. Let's look in the show authentication sessions interface FA102. And now I'm looking for the specific authorization, which is the filter ID value. So now I'm using this authorization as the access list. If I say show IP access list, interface FA102, I don't see the ACL being applied. Let's look at the show EPM session, IP 136.1.29.2. So I see the filter ID is being displayed. It depends, so with the DACL configuration, the show IP access interface worked to see the ACL being applied, while for the filter ID, I need to use the show EPM session IP configuration. To verify that the router was successfully authorized, I can say ping 136.1.29.2. So this works, which this confirms that basically the client is allowed full access to the network based on the content of this access list, which is show IP access list VLAN 29, which basically says permit ICMP any, permit TCP any. And I can also see the matches, which will increase because based on the routing protocol configuration between R1 and switch 1, between R2 and switch 1. So basically R2 and switch 1 run some routing protocol, which is EHRP, and that's why I see the counters from the ACL being increased. The third option would be to use the per user ACL, which pretty much means you need to disable this and you need to configure that as a Cisco AV pair. So I go Cisco, and I'm going to choose the AV pair, and I'm going to just specify the ACL content. So AV is this one, and I'm going to say IP colon enacle bound, let's say sequence number, just say it's 1, equals, let's say permit IP any. And I want to say save now. Let's verify that the authorization profile was successfully applied. Let's go to authorization profiles and then to MAB. I can go down at the bottom and see that the Cisco AV pair functionality is applied, which is this one. So now let's go back on the switch and let's say show authentication sessions. And I want to say clear authentication session ID, this one, to reinforce the authentication. So at this moment, I wait to learn the IP address of the client. Let's give it a while for that to happen. show IP device tracking all. It says active. In order to confirm that the ACL was applied, I need to see that EPM learned the IP address of the client. If I look at the show, which it did now. So now it finally processed, which means that the ACL should be applied at this moment. So let's say show authentication sessions. I see that it's a success. Show authentication sessions interface FA102. And now I should look for the authorization policy as a per user ACL. So now I'm using the per user ACL functionality to allow to authorize the client into the network. If I do show EPM session IP 136.1.29.2, I see the ACL being applied, which means if I go on R2 and I do ping again, this works, which basically confirms that the authorization is successful. So as we've seen, it doesn't matter which kind of authorization policy, which type of ACL you choose to configure, you always need the authorization network command so that the ACL can be applied, and you always need the IP device tracking functionality so that the switch can replace any source keyword from the ACL with the actual IP address of the client. And for the VLAN configuration to be assigned dynamically from ISE, you just need the AA authorization network command. Now, one other thing I need to show you is that if we go on switch 1, you basically see that the source keyword was not changed by the switch. It's still in the any format. This really depends on the switch code and depends on if you have multiple devices connected on the port, which this is going to be discussed into another topic. But even though it still shows up as any into the source, actually the switch enforces the client to send traffic only with that source. Because basically if I go on R2 and I change the IP address of the router, it should no longer be able to send traffic into the network. So for example, now R2 says I can ping switch 2, but if I go to, let's say, show IP interface brief, and I say show run interface gig 00, and let's go to gig 00 and change the IP address to IP address 136.1.29. Let's say 22.255.255.255.0, and if I want to ping again, this should not work. Which it doesn't. Because basically, as I said, the switch replaces the any keyword from the access list with the IP address of the learned client, but it doesn't necessarily mean that you'll see that in the show type of commands.